Hi everyone, it's Miss Costa here, and in this video we're going to go through the November 2017 Edexcel paper 1 for the higher tier. Okay, so in this first question I'm being asked to write 36 as a product of its prime factors. Now product means a multiplication of, and prime factors are factors that are prime numbers. So the prime numbers, you might just want to remind yourself, are 2, 3, 5, 7, 11, 13. They're the first few prime numbers. Remember, a prime number is a number that only has two factors, 1 and itself. And that's why 1 is not a prime number. And factors are just numbers that multiply into your given number. So they're always going to be smaller than your number, and they come in factor pairs. So for 36, what we want to do is start doing a little factor tree and find two factors. So two numbers that multiply to make 36, one of which is going to be a prime number. So the easiest prime number to use is generally 2. So let's start with 2. I know that 2 times 18 makes 36. Now when I get to a prime number on my factor tree, I circle the prime number and then I continue with anything that's left over. So I've got 18. Once again, I now need to find the factors of 18. So 2 times by 9 gives me 18. I can circle the 2. And now I find the factors of 9. So 2 factors that multiply to make 9. 2 does not divide equally into 9. So I'll try the next prime number, which is 3. And then I'm left with 3 times 3. So I need to write 36 as a product of its prime factors. So I can say 36. First of all, we can write it like this: 36 equals 2 times 2 times by 3 times by 3. You can then simplify it to 2 squared times by 3 squared, but it doesn't actually say leave your answer in index notation, so it's not necessary. It's helpful, but it's not the end of the world if you don't. So in this question, I've been given some unknowns, and whenever I have an unknown, I want to use algebra. So I'm told that Kiara is 7 years older than Jay. So J is the person who I know nothing about. I can say that J is my original unknown. So I'm just going to say J is X years old. Don't know how old he is, but however old he is, we're going to say it's X. I can then form an expression about how old Kiara must be, because if J is X years old, Kiara is going to be whatever J is plus 7, because she's 7 years older than him. I'm then told that Martha is twice as old as Kiara. So whatever Kiara is, Martha is double that. So I can put that in a bracket because it's double whatever Kiara is. And I could expand that if I wanted to. So 2 times X would give me 2X. 2 times 14, 7 gives me 14. Okay, I'm then told that the sum of their ages is 77. And sum just means the end result after you've used addition. So I can form my expression. I know that J's age is X. If I add Kiara's age to that, that's X plus 7. And then I add Martha's age, that's 2X plus 14. I know that all of these ages, these expressions must sum to make 77. So I've got an expression, and now what I want to do is just simplify it. So collect all of your like terms. I've got X plus 2X, which is going to give me 4X. And then I've got 7 plus 14, which is 21. So 4X plus 21 must equal 77. If I write that up here, 4X plus 21 equals 77. What would I then do? I need to solve this equation to find out what the value of X is. So I can start by subtracting 21 from both sides. And I'm left with 4X equals 77 take away 21 is going to give me 56. Now I know that 4X is 56, so what do I have to do to both sides? I'm going to divide by 4 because that cancels. And whatever I do to one side, I have to do to the other. And 56 divided by 4, if you don't know that off by heart, this is a non-calculator, so just use the bus stop method. We say, how many times does 4 go into 5? Once, remainder 1. How many times does 4 go into 16? 4 times. So 56 divided by 4 is 14. Now they're saying, find the ratio of J's age to Kiara's age to Martha's age. So we know that J is X, so we can say that's 14. We know that Kiara is X plus 7, so 14 plus 7 gives me 21. And then Martha is 2x plus 14. So 14 times by 2 is 28. And then 28 plus 14 gives me 8 plus 4 is 12, sorry. 2 plus 1 plus 1 is 4. So I'm left with 42. So the ratio would be 14 to 21 to 42. To double check, what must their ages add up to? Well, I'm told that their ages sum to make 77. So if I just did 42 plus 21, that gives me 4 plus 2 is 6, and then 63 plus 14 gives me 77. So I know I've done it right. So in this question, I've been given a parallelogram and some kind of triangle on top of it. I'm told that ABCD is a parallelogram, which is important because I then know that the laws of parallel lines are going to be able to be used for this question. I know that EDC is a straight line and that F is the point on AD, so that BFE is a straight line. So we're dealing with straight lines here, which is excellent. They've told me some of the angles and I'm asked to show that angle ABF is 70 degrees. So ABF is this angle here. And don't try and start from there. When you're doing a show that question, you want to start from the very beginning to show how you ended up to getting to ABF equals 70. So let's just think about what we can figure out. And it says give a reason for each stage of your working. So be sure to give that reason, even if that reason is angles on a straight line sum to 180 or angles in a triangle sum to 180. Whatever the reason, as simple as it is, state it. So what can we do first? Well, we know in a parallelogram or in parallel lines that the co-interior angles are going to sum to 180 degrees. So co-interior angles sum to 180 degrees. So we can figure out that this angle here must be 180 take 75, which is going to give me 105 degrees. So I know that this angle here is 105 degrees. Now, there's another rule that you may not be familiar with, which is that opposite angles in a parallelogram are equal. So let's just write that one down. Opposite angles in a parallelogram are equal. Therefore, angle BAF is going to be 75 degrees. So I've got this angle here is 75 degrees. Also should have done full working here to say therefore angle CDF is 105 degrees. Okay, so that's step one, that's step two. And then what have I got here? Over here, I've got two straight lines that intersect. And whenever you have two straight lines that intersect, the angles that are opposite each other in that X form are called vertically opposite angles, and I know that they are equal. So vertically opposite angles are equal. Therefore, I know that angle AFB is going to be 35 degrees because it's vertically opposite to this one here. So now I've got a triangle over here, AFB. And what do I know about angles in a triangle? I know that angles in a triangle sum to 180 degrees. So therefore, angle ABF is going to be 180, take away 75, take 35, which equals 70 degrees. So with each little bit that you've worked out, just make sure you give a reason. There's obviously different ways you can do this. As long as you, for whatever you've worked out, you give a reason, you'll be absolutely fine. So in this question, I'm dealing with a circular logo, and it's a non-calculator paper for circles. So whenever I'm doing non-calculator papers, generally you want to leave your answer in terms of pi. It just is, leaving your answer in terms of pi literally is one step less than what you would do if you did a calculator. So let's have a look at what's going on. First of all, let's just recap that the area of a circle is pi r squared. It always just helps to write the formula out because in the exam you're under pressure and you just might do some crazy things. So write the formula out. I know that the diagram shows a logo made from 3 circles and each circle has the same center, which is O. Daisy says that exactly 1/3 of the logo is shaded, and I need to see if she's correct. So how can I work out what proportion of the logo is shaded? Well, first of all, I want to work out the area of the large circle. And how do I work out area? It's pi times by radius squared. So what's the radius of the large circle? It's going to be all of this from the center to the outside is the radius. So therefore 4 plus 3 plus 3 is 10. So I'm going to do pi times 10 squared, and 10 squared is 100. So I can just write that as 100 pi. So circle 1 is 100 pi. Let's do the same for circle 2. So the area of the middle circle is going to be pi times by, and the radius of this one, so let's try it again. So the middle circle is going to go from the center to the outside of the middle circle, which is here. So that's going to be pi times by 7 squared, which is pi times by 49, which I can leave as 49 pi. So my second circle is 49 pi. And then let's do the final circle, the tiny little one in the center. So this little circle, area of small circle is pi times by 4 squared, which is going to be pi times 16, which is 16 pi. Okay, so I know the area of all 3 of my circles. I actually don't know if I needed the area of the last one, but we just did it for fun anyway. And I need to work out what proportion is shaded. And so to work out the area of the shaded bit, what I want to do is work out the area of this middle circle. So imagine it's not a shaded circle, okay? And then I want to subtract this from it because this has been taken out. So basically work out the area of the full circle, of the middle circle, and then subtract the area of the smaller bit. That's how we always work out shaded area. So how can I figure out what the shaded area is? I know that the middle circle is 49 pi, and I know that the small circle is 16 pi. So I can just do a subtraction. 49 take away 16 is going to give me 33 pi. Okay, so the shaded area, this part here, is 33 pi. Now I know that the total area, because the total area of the logo is this bit here, the whole thing, and that's 100 pi. So this is actually quite a sneaky question because we end up getting very close to a third, but you need to know the difference between exactly what a third is, and that's perhaps a little bit sneaky. So how do I work out what proportion of the logo is shaded? Well, I know that 33 pi is shaded out of a total of 100 pi. So what I can do is turn that into a fraction and divide what I can. So remember, when you've got fractions and the terms are it's just one term that's being multiplied, you can divide, because anything divided by itself is 1. So pi over pi is 1. So I can just cancel that out, and I'm left with 33 over 100. Now, if I do 33 over 100, that gives me 0.33. Okay, so 0.33, or 33% of the logo is shaded. And what is a third as a percentage? Well, a third as a percentage is 0.3 recurring, which means it would have to be 0.333333333 going on until infinity. So therefore, Daisy is incorrect. 33% of the logo is shaded. So she was very close, but she was 0.333% off. Okay, so here I'm being asked to find an estimate for the mean of the weekly earnings. Now, this is a grouped frequency table, and with a grouped frequency table, what it means is I'm never going to know what the exact values are. I just know that one person earns between 150 and 250 pounds. 11 people earn between 250 and 350 pounds. So the reason it says estimate is because what we have to do is we have to figure out what the midpoint is of the class intervals. And the class intervals are just the things that tell us, like here, the class interval is 150 to 250. That's the little bracket that one person earns between. So I find the midpoint of my class interval. So that would be 200. Over here, that would be 300, 400, 500, and 600. Okay. And then what I do is I multiply my midpoint times by the frequency. Frequency just means the amount of people. So I can extend my table. Generally, when you're doing an estimate for the mean, whether it's a frequency table or a grouped frequency table, you're always going to want to extend your table, and you're going to want to have a column for the midpoint and your final column for the midpoint times by the frequency. Sometimes you can just do your midpoint in here and do it like that. So you could have done 200 times by 1, 300 times by 11, like that. But you do whatever works best for you. So then I multiply my midpoint times frequency. So 200 times by 1 is going to be 200. And then 300 times by 11. Well, I know that 300 times by 10 is going to give me 3,000. So I add on another one lot of 300. So that'd be 3,300. 5 times 400. 5 times 4 is 20. And then I add on the 2 zeros. 0 times by anything is 0. And 3 times 600, well, 3 times 6 is 18. And I add on the 2 zeros. So now I've filled out my column. What I want to do is find the total. So I add all these values together. And then I divide by the total frequency. So a little formula that you can use if memorizing formulas works well for you. The mean from, or should I say an estimate for the mean from a group frequency table is going to be your total, your midpoint times frequency total over your total frequency. So this box here. So let's add them all together. So 3,300 plus 2,000 plus 1,800 plus 200 is going to give me 0, 0. 8 plus 2 is 10 plus 3 is 13. 3 plus 2 is 5, 6, 7. So that's 7,300 is my total over here. And then the total frequency is 20 because I'm told that in the question. So what do I want to do? I want to do 7,300 divided by 20. And once again, it's a non-calculator paper. So if you feel confident using long division, you do that. If not, then you can just turn it into a fraction and then simplify. So let's start by dividing by 10. I can just chop off the zeros. So that's the same as 730 divided by 2. And then, well, 730 divided by 2. Either you can do it in your head or use the bus stop method if you just want that extra confidence. 2's into 7 go 3, remainder 1. 2's into 13 go 6, remainder 1. And 2's into 10 go 5. So that would be 365 as my final answer. Okay, so now I am being told that Nadia thinks that the mean may not be the best average to use to represent this information. Do you agree with Nadia? Well, what is the mean telling me? It's trying to tell me the average salary, and according to the mean, the average salary is 365. But let's think about how many people actually earn 365. That's not the majority. So only 8 people out of 20 earn £365 or more. Now with the mean, what we do is we take into account all of the values. So over here, the people that are earning £550, what we can do is call them outliers because they kind of skew the data. The majority of people earn between 250 and 450. And then we've got one person over here that also skews the data that earns, he could or she could earn £150. So with the mean, any outliers skew the data. And in this case, maybe a more representative average would have been the median, because that takes into account like the middle part of the data and the average of that. So with the mean, any outlier, skew the data, the average salary is higher than what most people earn. And so therefore it's not really representing or giving me the information that I want. Okay, so in this question I've been given a rectangle and told that all measurements are in centimetres, and I've been given the area of a rectangle. Now, how do you work out the area of a rectangle? You just do base times by height. So let's look at what I am being asked to do. I'm being asked to show that y equals 3, which means I need to find out the value of y. Now, what can I do with all of the information I've been given? Well, I know that in a rectangle, opposite sides are equal, the same length. So therefore, I know that this expression must be equal to this expression. So I can just form an equation for myself. So 2x plus 6 must be equal to 5x, take 9. Now I've got a double-sided equation, so what I want to do is move everything around so that I get my x variables on one side. So with equations, when you're solving them, remember you can move things as many times as you want or need to, as long as whatever you do to one side, you do to the other. So let's start by subtracting the smallest x variable. So if I subtract 2x from both sides, I cancel it on this side and I'd be left with 6 equals 3x, take 9. Then I can add 9 to both sides and I'd be left with 15 equals 3x. So if 3x equals 15, x must equal 5. And if I know that x is 5, I can now use that value to figure out what the length of the side of my rectangle is. So if x is 5, 2 times by 5 plus 6 is going to be 16. So I know that the length of this side is 16. To just double check if I've done it right, what's 5 times 5? 25. 25 take 9 is 16. So it works for both equations or both expressions. So I know that the side of the rectangle is 16. I know that 16 times by y must equal 48, because how do you work out the area of a rectangle? You do base, which would be y, times by height, which is 16. So 16 times y is 48. And how could I solve this to find what the value of y is? I could divide both sides by 16. So y would be, and once again, if you are not confident with division, just turn it into a fraction and simplify. So divide by 2, that would be 24 over 8. Divide by 2 again, it would be 12 over 4. 12 divided by 4 is 3. Okay, so that's how we do that. So the key is to think about, what do I know about this question? Well, I know the opposite sides in a rectangle are equal. If that's true, then I can set up two equations and make them equal to each other. Okay, so in this question, I have been given a graph of what should be a quadratic because it's got an x squared in it. Now, whenever you have a quadratic graph, you know it's going to look like a curve, like a little upside down rainbow. So I need to write down one thing that is wrong with Brogan's graph. Well, Brogan joined everything together with what looks like a ruler, because he joined each coordinate to the next coordinate with a straight line. So Brogan should have drawn freehand, so without a ruler, or you could say should have drawn freehand. The graph should be curved. Anything of that sort of nature. It should look like this, okay? Not straight little line chunks. Okay, so in this question, I'm being asked to put these decimals in order of size, and some of them are recurring. Now, the best thing to do when you're ordering decimals is to just write them out so that you can compare them. So if I write all of these out like this, 0.246 over here, this part's recurring, and 0.246. Now, If I write these decimals out just as they have been given, all of them actually have the same place value up until the third decimal point. So the key here is to keep the decimals going in the pattern that they are. So 0.246 recurring means that 4, 6 is going to keep on going. So that would be 4, 6, 4, 6. 0.246 means the 6 keeps on recurring. 0.246 means the whole thing is recurring. So remember that these little points here, wherever they are, the first point and the last point, whatever's in between them, the whole part is recurring. And then 0.46 has nothing recurring, so everything would be 0, 0. So now that I've continued my decimals on, I can start to compare them. I can look at, so when you've got decimals, you've got your decimal point, then you have the tenths column, the hundredths column, the thousandths column, and so on. So the further away from the decimal point that your number gets, the smaller it is. The largest place value is this column, then this column, then this one. Okay, so I'm going to look at the fourth decimal, and the lowest value is 0. So my first number is going to be 0.246. So I can get rid of that one. Then I look in this column, and 2 is the next one. So 0.246 with the recurring over here would be the next one. And then 4 is the next smallest value. So 0.246 recurring like this. And then the last one is this one over here. So 0.246 with the 6 recurring. So just compare them, continue the decimal on, and you're looking for the smallest place value of the one that you find. Okay, so in this question, I'm told that James and Peter cycled along the same 50 kilometer route. So both of them cycled along a 50 kilometer route. James took 2.5 hours. So I could just write that as a decimal, 2.5 hours to cycle the 50 kilometers. Okay, so I'm then told that Peter started to cycle 5 minutes after James started to cycle, and he caught up with James when they had both cycled 15 kilometers, and that they both cycled at constant speeds. So what I can first do is figure out what James's speed must be, because I have all of the information that I need in order to do that. So remember, speed is distance over time. So then the distance is 50 and the time is 2.5. This is a non-calculator paper, so you could, you could either do 50 divided by 2.5 if you're confident with dividing decimals, turn that into 500 divided by 25, or you could turn it into a fraction. So 50 is being divided by 2.5. So 50 is being divided by 2.5. If I turn that into an improper fraction, that would be 5/2. So 50 is being times by 2/5. So that would be 100 divided by 5, which is 20. So James's speed is 20 kilometers per hour. So let's just write that up here. And then what I need to do is compare it. So I know that James cycled at a constant speed of 20 kilometers per hour. And then Peter started to cycle 5 minutes after James started to cycle, and he caught up with James when they had both cycled 15 kilometers. So that means that, okay, so now I need to figure out how long it took Peter to cycle 15 kilometers. So I know, James, I know that James's speed is 20 kilometers per hour. So I know his speed, write the formula up again, speed is distance over time. So speed is distance, 15 over time. I don't know his time yet. How can I work out what the time is? I can switch these around. So the time is going to be 15 over 20, which would simplify to 3/4. Okay, so that means that it took him 3/4 of an hour. 3/4 of an hour is 45 minutes. So Peter started to cycle 5 minutes after James started to cycle. So that means that he must have done the 15 kilometers. So Peter's speed, he must have done the distance, 15 kilometers, in 40 minutes because he started to cycle 5 minutes after James. So we take 5 minutes and it's 40 minutes. But remember, when you're dealing with time and speed, you always want to write your time in terms of hours. So the 40 minutes we're going to need to turn into hours. So what you can do is write that as a fraction of an hour because there's 60 minutes in an hour. So 40 over 60 would be 4/6, which would simplify to 2/3. So to find out Peter's speed, what I would need to do is 15 divided by 2/3 because 40 minutes is equivalent to 2/3 of an hour. And once I'm dividing decimals, what do? I keep, change, flip. So that would become 15 times by 3 over 2. 15 times by 3 is 45. And 45 divided by 2. If I can't do it in my head, just use the bus stop. So 2's into 4 go twice. 2's into 5 go twice, remainder 1. And 2's into 10 go 5. So therefore Peter's speed is 22.5 kilometers per hour. So this one is quite a tricky question because there's a lot to read or interpret. But we start by just figuring out what James's constant speed must be. Then we need to figure out how long it took him to cycle 15 kilometers. And then using that, we can finally figure out how much time it took Peter. And the key thing to always remember with speed, distance, time is whenever you're dealing with minutes, you want to convert them into hours. And you do that by writing it as a fraction of an hour. So here I've got some fractional indices. So remember, when you're dealing with fractional indices, over here, the denominator of the fraction, that tells you what you want it to do it to the root of. So for instance, it's the root of 2, which is the square root. If it was 100 to the power of a third, you'd want to do the cubed root. Okay, if it was 100 to the power of a quarter, it would be to the root of 4. So the denominator always tells you what you want to do it to the root of, and the numerator tells you what you want to do it to the power of. So I want to do the square root of 100 to the power of 1. So I didn't really need to write that bit because the power of 1 doesn't change anything. What's the square root of 100? 10. And because it says write down the value, you need to actually work out the value of it, which is 10. Similarly, I do exactly the same thing over here. So with fractional indices, this tells me what I want to find the root of. So I'm going to do the cubed root of 125. And then this tells me what I need to do it to the power of. So I need to then do it to the power of 2. So first, let's work out the cubed root of 125. Well, the cubed root of 125 is 5. So hopefully you know your cube numbers up until at least 10, because it's important to be able to recognize them, especially on a non-calculator paper. And then you've got 5 squared. And what's 5 squared? 25. So this is a nice simultaneous equations question because it's actually put into context so you can see like how simultaneous equations work in real life. Now, they haven't written it to you in terms of algebra, so it's up to us to do that. So 3 teas and 2 coffees have a total cost of £7.80. So I can just use T as the algebra for a tea and C for a coffee, and that must equal £7.80. So all I've done is I've turned these words into an algebraic expression, into an algebraic equation. T represents the teas and C represents the coffees. And then I do the same with the next one. 5 teas and 4 coffees have a total cost of £14.20. Okay, so this happens in real life. Sometimes you pay for something and then you don't actually know what the individual things cost. But with simultaneous equations, we can actually work that out. So the first thing you want to do when you've got simultaneous equations is you want to pick one of the variables, either the t's in this case or the c's, and you want to make sure that they are the same. So the easiest thing to do in this case would be to manipulate the c's. Now, I want to get them so that they're both exactly the same. So I want to make it so that as though there's 4 coffees. So what can I do? I can multiply this whole equation by 2, because then that would turn 2c into 4c, and then the variables would be exactly the same. So step 1 is you want to make sure you have one variable that is the same. Okay, so if I multiplied this by 2, that would give me 6t plus 4c equals £15.60. Okay, so this is this equation just multiplied by 2. We have to multiply each little individual part by 2. And then I'd write out the next equation underneath. And now, because I have something that has the same variable, so if I just imagined it, so 6t over here plus 4c, it gives me £15.60. And if I did the same here, 5t, oh, let's do it pink, 5t plus 4c equals £14.20. If I subtracted these equations, so I'm like, okay, what do I have in common? Because if whatever I have in common I can eliminate, I get rid of these, but I also have to subtract everything else. So I get rid of 5 of these. So I'm just left with one little coffee here, and then whatever £15.60 take £14.20 is. So whenever you've got simultaneous equations, you're trying to find the same variable, and then you decide whether you add or you subtract the equations. So in order to eliminate the variable, in order to get rid of these 4 coffees, what am I going to have to do? I'm going to have to subtract. So you put a subtraction sign here, and then 6t take away 5t just leaves you with t. 4c take 4c cancels, that's why I'm doing this. And £15.60 take away £14.20 would give me 40 pence, £1.40. Okay, so you figured out that the value of one of the t's is £1.40. Now, once you know the value of one of your variables, what you can do is substitute it back. Okay, so substitute it back into one of the equations, and it's always better to just do the smallest one because it's just less work. So I now substitute it back into the equation. So if t is £1.40, £1.40 times by 3 is going to give me 0 times 3 is 0, 3 times 4 is 12, 3 times 1 is 3, plus 1 is 4, so that would be £4.20. So £4.20 plus 2c must equal £7.80. So 2c is going to be £7.80. Take £4.20, which is £3.60. And if 2 coffees are worth £3.60, I'm just going to divide both sides by 2. So a coffee is going to be £1.80. Okay, so you know the price of your tea is £1.40 and the price of your coffee is £1.80. So just as a recap, with simultaneous equations, find a common variable. If they're not common, then you need to manipulate times the equation by something. Line them up, decide whether you have to add or subtract them in order to eliminate that variable. Step 3, subtract them or add them and find out one variable, so in this case the t's, and then you substitute the value of that into the equation in order to get your next variable. Okay, so in this question, I need to draw a box plot. So just a quick recap with what we do when we have a box plot. We have a few key values. So the end of the box plot, this is the lowest value. The highest value is going to be here. The median is this middle part here. The upper quartile is the top bit of the box plot, and the lower quartile is over here. So the upper quartile is 3/4 of the data. Lower quartile is 1/4 of the data. That's why it's called quartiles, and the median is 1/2 of the data. So let's look at the information we've been given. We've been given the lowest value, which is 154. Now let's quickly look at our scales. So I know this is 155. There's 5 squares, so between 150 and 155. That means that each square must be going up by 1. So 154 is over here. The median is 165, so I can plot that here. The lower quartile is 161, so I can plot that here. The interquartile range is 7, so that tells me the interquartile range is the upper quartile, take the lower quartile, so the difference between the lower quartile and the upper quartile. So therefore 161 plus 7 is going to tell me the value of the upper quartile, so that's going to be 168. Okay, so the interquartile range is the difference between the lower quartile and the upper quartile, so this difference must be 8. So 168 is over here. Then I can join this together. Once I've got my lower quartile, median and upper quartile, I can join this here. And I'm told that the range is 20. So the range is the difference between the lowest value and the highest value. This is the whole range. So therefore the least height is 154. So 154 plus 20 is 174. So that is going to be my greatest value. So I can plot that in. 174 would be over here. And that's what your box plot should look like. Okay, so in this question, I've been given another box plot that shows the information of a group of Year 7 girls, and I need to compare the distribution of heights of Year 7 girls with the distribution of heights of Year 11. Now, these questions come up so often, and whenever you're comparing the distribution, you always want to compare the median and then also compare either the range or the interquartile range, because that is the spread of data. So I'll go with the interquartile range. And then we want to put it in context. Okay, so let's look at what's happening. So the median of the Year 11 girls is 165, and the median of these girls, let's have a look at what's happening. So this is 155, so that would be 156, 157.5. Okay, so the median is a lot lower for the Year 7 girls, and you can put the values if you want, 157.5 versus 165, which suggests that overall the Year 7 girls are shorter. Okay, so you're saying what is happening with the median, whether it's lower or higher, and then what that suggests in context. And then let's do the same for the spread of data. So the interquartile range, well, this value seems to be, this is not a very nice box plot. So let's do the upper value first. So that would be 160, 1, 2, 3, 4, 5. Okay, 165, and the lower value would be 155, take away 1, so 140, 154.5. Okay, so the interquartile range for the Year 7 girls is going to be 165, take 154.5, which is going to give me 10 point, I wrote that the wrong way round, 10.5. So the interquartile range for the Year 7 girls is 10.5. So when the interquartile range is larger, that means that the data is more dispersed, which means that there's a greater variety of data, which means it's less consistent. It's less consistent. So the greater the spread of data, the less consistent the data is. So who's got the greater range? The Year 7 girls have a greater interquartile range, suggesting the data is less consistent. So what that means is that there's a greater variety of heights. And that makes sense because if you think about it, in year 7, different people, like all throughout secondary school, different people grow at different times. So some people shoot up in year 7, some people don't shoot up until year 11. So the key thing is whenever you're having to compare distribution, you always compare the median and the spread of data and you put it into context. You explain what that means. Okay, so in this question, I'm told that a factory makes 450 pies every day and that they're either going to be chicken or steak pies. And each day, Milo takes a sample of 15 pies to check. And the proportion of the pies in his sample that are chicken is the same as the proportion of the pies that made that day that are chicken. So on Monday, Milo calculated that he needed exactly 4 chicken pies in his sample. So out of his whole sample, which is 15, 4 of them were chicken pies. And that is the same proportion as the total amount of chicken pies made. So I can set up an equivalent fraction. I know that 4 out of my 15 from my sample must be equivalent to something over 450. So then what I need to do is figure out how did I get from 15 to 450? Well, what I can do the reverse. So I can just do 450 divided by 15 to figure out what I would need to multiply by. So 450 divided by 15, I know that 5 is going to be a common multiple, so a common factor. So 15 divided by 5 is 3, and 450 divided by 5, if I didn't know that, then once again, just to use the bus stop method. So 5s into 4 don't go, 5s into 45 are 9, and 5s into 0 is 0. So that would give me 90 over 3, which is 30. So then you know that the equivalent fraction, if you times this by, jumped ahead there. So that means that 450 divided by 15 is 30. So this divided by 30 would get you back to this fraction. So to times by 30, you get from 4, times it by 30, you get 120. Okay, so we did this division to figure out what we needed to divide by to get to this way, and then you can do the opposite to get to the other fraction. So 120 chicken pies. So in this question, I'm told that on Tuesday, the number of steak pies Milo needs in his sample is 6, correct to the nearest whole number. And he takes at random a pie from the 450 made on Tuesday, and I need to work out the lower bound of the probability that the pie is a steak pie. So let's just think about our sample size again. I know that there are 15 pies in the sample, and his sample is 6, correct to the nearest whole number. So what are the whole numbers surrounding 6, 5 and 7? And I want to work out the lower bound. So the lowest possible thing it could have been before it rounded up to 6. That would be 5.5, because if it was 5.49 recurring, that would round down to 5 pies. So the lowest possible amount of pies that could be in his sample is 5.5. I need to then turn this into something out of 450. And from the previous question, I already know that if I times 15 by 30, I get to 450. So I'm going to have to do 5.5 times by 30. How could I do that with a non-calculator? I could break that up into this. So 5.5 times by 10 is 55. And then 55 times by 3 is going to be 165. So you know that it's 165 pies, but it says write it as a probability. So make sure you always read the question carefully. So that would be 165 over 450. Okay, so this is a slightly tricky question. Whenever you're dealing with ratios, equivalent ratios, always bear in mind this one thing. So let's just look at an equivalent ratio. So I know that 2 to 3 is the same as 4 to 6, because all I've done is I've doubled that. Okay, so I know that they're equivalent ratios. Now, how could I express this? Well, I know for a fact that 2 over 3 is also equivalent to 4 over 6. So when you're dealing with equivalent ratios, what you can do is turn them into fractions because then you're able to manipulate them. So you might just want to think back to this example. Whenever you're stuck, just always try and think it back to a numerical example and see how it can make sense. Okay, so I know that a ratio divided by another ratio is equivalent. It's going to be in the same proportion as the other equivalent ratio over the ratio. So let's see what that means. It means that I can write y plus x over y minus x must be equal to k over 1, because I'm following the same rules as I did here. Now that I've got fractions, I can try and manipulate them to solve them. So I know that anything divided by 1 is just 1. So that would just leave me with this. And then what do I want to do whenever I've got a denominator with algebra? I just want to multiply it by that denominator to get rid of it. So if I times both sides by y minus x, I'd be left with y plus x equals k, y minus x. And then what I need to do, I'm being asked to show that y equals something, so I just need to rearrange everything to make y the subject. So let's expand the brackets. Y plus x is going to be ky minus kx. And if I want to make y the subject, I know that I need to bring together all of the y terms. So let's think about what it's wanting me to do, because there's a few ways we can do this. I know that x, if I factorised it, I want to get it to the form k plus 1. So therefore, let's move the x's first. Let's add kx to the other side. So y plus x plus kx equals ky. So now I can move the y. So x plus kx equals ky minus y. And then we can do some factorising. So whenever you've got an equation where you've got x variables and y variables and you've got more of one of each, just split them up so that all the x variables are on one side and all the y variables are on the other side. Then you can factorise. So let's factorise this. So if I take x out of the equation, I'd be left with k plus 1. Or in this case, it would have been 1 plus k, but I know that this is the form they want it in. And then over here, if I take y out of the equation, I'd be left with k minus 1. And what's the next part? Well, I want to get y on its own. So I'm going to divide both sides by k minus 1. So x, k plus 1 over k minus 1 equals y, which is what I have been asked to show. Okay, so in this question, I'm being asked to prove algebraically that x, which has a value of 0.436 recurring, can be written as 24 over 45. So I know that x is 0.436 recurring. And what I can do is manipulate this by timesing it by 10 or 100 or 1,000 in order to just shift the place value. So if I multiplied it by 10, then I'd be left with 10x equals 4.36 recurring. So I've shifted it so only the recurring part of the decimal is after the decimal point. If I times it again, I get 100x equals 43.63 recurring. And if I times it again, I'd end up with 1000x equals 436.36 recurring. Now what you're looking for is so that the part after the decimal point is your recurring bit. So in this case, it's 0.36, and I have that with 10x, and then I need to look for when I next have that again. So with 100x, I don't have that, but with 1000x, I do. So I end up with 0.36 being after the decimal point for both of these. So then I can use both of these and subtract them. So if I say 1000x equals 436.36 recurring, and I subtracted 10x from it, what I end up then doing is getting rid of the recurring part of the decimal, because anything to take away itself gives you 0. So 0.36 take away 0.36 is going to give you 0. And, oh, I wrote that out wrong. That should be 4.36. And then 436 take away 4 is going to give you 432. 1000 take away 10 is 990. So you know that 990x is equal to 432. We can divide both sides by 990 so that I solve it to get x. So x would be 432 over 990. So you've turned your decimal into a fraction. Now we need to prove that it can be written as 24 over 55. So what I just want to do is start simplifying it. So I know that x is 432 over 90. So the first thing I could do is divide by 2. So 432 over 990 divided by 2 is going to give me, and if this is non-calculator, so let's just do it with the bus stop method. 2's into 4 go twice, 2's into 3 go once, remainder 1, 2's into 12 go 6. So that's going to be 216 over, and then let's do 990, 2's into 9 go 4 times, remainder 1, 2's into 19 go 9 times, remainder 1, and 2's into 10 is 5. So now I've got a slightly simplified fraction. Now I know that I'm not going to be able to divide by 2 because 5 doesn't divide by 2. So what I can do is try the next prime number, which is 3. So 216 divided by 3. 3's into 2 doesn't go, 3's into 21 is 7, and 3's into 6 is 2. So that would become 72, and then 495 divided by 3. 3's into 4 is once, remainder 1. 3's into 19 is 6, remainder 1, and 3's into 15 is 5. So I'm left with 72 over 165. Once again, I need to think what I can divide by. Well, let's try 3. So 3's into 72 goes twice, remainder 1, and 4. So that would be 24. And it's looking promising because that's what I want my final answer to look like. And then 165 divided by 3. 3's into 16 go 5, remainder 1, and 3's into 15 are 5. So that is how you would show that it can be written as 24 over 55. If you recognised that you could divide it by 9, you could start there, but this is just showing how you'd break it down. So in this question, I'm dealing with direct proportion. I'm told that y is directly proportional to the cubed root of x. So I can just start with my statement of proportionality. So y, this little sign here, means is directly proportional to the cubed root of x. From this statement, I can now set up an equation. If y is directly proportional to the cubed root of x, it means it's going up in a linear fashion. And I can set up an equation. Obviously, y isn't equal to the cubed root of x, otherwise I'd just say that. So I know that there's a multiplier involved. So with direct proportion and inverse proportion, we use k. So we just say y equals the cubed root of x multiplied by k, the cubed root of x times by something. Now I've been given two values. When y is 1 and a sixth, then I can just quickly turn that into an improper fraction. So that would be 7 over 6. When y is 7 sixths, x equals 8. So I can substitute those values into this equation. So I know that 7 sixths is going to be k times by the cubed root of 8. And what's the cubed root of 8? That would be 2. So 2 times 2 times 2 makes 8. That's what's the cubed root. So I know that 7 sixths is equivalent to 2k. To solve what k is, I'm going to need to divide both sides by 2. So 7 sixths divided by 2, I can write it as a fraction. Remember, when you're dividing fractions, you keep the first fraction as it is, change the sign and flip the last fraction. So that would be 7 sixths times by 1 over 2. 7 times 1 is 7 and 6 times 2 is 12. So I know that k must equal 7 over 12. So I've done all of this initially in order to find out what the value of k. They're always going to give you the value for y and x, and you use that to find k. Because once you've found k, you have a general formula that you can use to find anything that they ask you. So I know that the general formula would be y equals 7 over 12 cubed root of x. So for the next part, I am being asked to find the value of y when x is 64. So I'm just going to substitute that into this general formula that I've got, 7 over 12 times by the cubed root of 64. And what's the cubed root of 64? that would be 4. So I just multiply. To turn any number into a fraction, I write it over 1. So y is going to be 7 times 4, which is 28, divided by 12. And I can just simplify this. So divide by 2 would be 14 over 6. Divide by 2 again would be 7 over 3. So y is 7 over 3. Okay, so we've got an algebraic proof question. Now this is sometimes a question people shy away from because they're like, what are you asking me to do? But all it's literally asking you to do is fiddle around, expand some of the brackets, see what they expand to, simplify them, and then see how it can lead to what they want. So in this question, they're saying prove algebraically that the sum, which means we're going to be adding of this and this, is always a square number. So what is a square number? A square number is anything multiplied by itself. That's it. Okay, so as long as we can prove that something is being multiplied by itself, then we're proving that it's a square number. So let's have a go at simplifying this. So a half n times by n plus 1, that's going to give you a half n squared plus a half n. And then let's expand the next bit. So a half times by n plus 1, n plus 2. Let's expand the brackets first. So n times n gives you n squared. N times 2 is 2n. 1 times n is n. And 1 times 2 is 2. And let's simplify that. That would be n squared plus 3n plus 2. And remember, it's being times by a half. And I'm going to be adding these because it says the sum. So I've got a half n squared plus a half n plus, I'm going to have to multiply this whole thing by a half. So that would be a half n squared plus 3 over 2n plus 2 over 2. So 2 over 2 is just going to be 1. So I can just change that to 1. So now what can I bring together? Well, a half n squared plus a half n squared is going to just give me 1 whole. So that would be n squared. And then a half n plus 3 over 2n. So a half plus 3 over 2 is going to give me 4 over 2, which is 2. So that would simplify to 2n. And then I'm just left with 1. So I know that these two expressions, I do them separately, but I know that when I add them and expand them, they give me n squared plus 2n plus 1. So what can I do now? Well, I'm trying to prove that it's a square number. So I'm trying to get it so that I can show that something times by itself can be brought out of this. So let's try factorising. So if I factorise this, I need two numbers that multiply to make 1 and then sum to make 2. So the only factors of 1 are 1. So I know it's going to be n plus 1 and then n plus 1. And how else can I write this? Well, I could write this as n plus 1 squared. So I've shown anything, I could do a little bit of writing. So any number multiplied by itself is a square number. Therefore, and these little 3 dots just mean therefore, half n plus 1 plus half n plus 1 n plus 2 is a square number as it simplifies to n plus 1 squared. And obviously that means that it's being squared, multiplied by itself, which means it is a square number. Okay, so in this question, I'm being asked to enlarge shape P by scale factor -1/2 with centre of enlargement 0, 0. So just a reminder that a negative, when you're enlarging by a negative scale factor reverses the direction. So when we're normally doing enlargements, what we do is we think, okay, how do I get from my shape? I go 2 and then 3 up, and then I'd do the same in this direction. So I always start from the center of enlargement and I go towards my shape. Now, when it's a negative scale factor, what I do is I start from the shape and go towards the center of enlargement and beyond. Okay, so that's for the negative part. And then a fractional part, well, a half just means that whatever the shape is, it's now going to be a half of that. And whatever the distance from the shape to the center of enlargement is, it's going to be half of that on the other side. So let's put this into practice. So fractional just means half of the shape. So each side is going to be half of its original length. So let's pick this point and I can label that with an X. What am I doing to get to my center of enlargement? I'm going down by 3 and across by 2. So I then need to do half of that. So down by 1.5, because that's 3, that's 2, so I half it. Down by 1.5 and across by 1. So that is where my new little X point is going to be. Let's do the same with this point, and I'll just do it as a circle. What am I doing? I go down by 3 and across 4 to get to my center of enlargement. So I'm going to do half of that. So half of 3 is 1.5, half of 4 is 2. So my little circle is going to be there. And for my last point, what shall I do? I could do a triangle. So this little point here, actually no, I'll do a star. That's much nicer. So a little star. What's happening? I go down 7 and across 2. So I'm going to have to do half of that. Down 3.5 and across 2. So my little star is going to be there. And once you've got all of your points, all you want to do is just join them up and label your image Q. So this is going to be Q. So the key thing is just with a negative, when you're enlarging by a negative, you reverse the direction. And with a fractional, it just means you multiply each side by a half. And the distance as well. And that's how we do that. Okay, so here we have a really fun, nice coordinate problem. I'm told that ABCD is a rectangle, so this shape here is a rectangle, which means that all of its, well, not all of its sides, but this side and this side will be parallel, and this side and this side will be parallel and also equal. I'm also told that A, E, and B are points on the straight line L. So this is the straight line L, and it has an equation of, let's rearrange that. So you always want your straight lines to be in the form y equals mx plus c. So let's rearrange that. Let's take x from both sides. So 2y equals 12, take x. And then I'm going to have to divide by 2 to make y the subject. So y equals 6, take away a half x. I could rearrange that to be y equals minus a half x plus 6, but it doesn't really matter. What I'm looking for is the gradient. So generally you're going to be given 2 lines, and one of them you're going to use in order to work out the gradient of it. So I know that the gradient of line L is minus a half. I could just write this here as the whole equation, y equals minus a half x plus 6. So I know some information, and the gradient is minus a half. Now, what have I actually been asked to do? So I was given that information and I used it, and I'm told A and D are points on the straight line M, and that AE equals EB. So this length here is equal to this length here. So essentially, if AE equals EB, then that must mean that this is the midpoint, because they were equal, and this must be the halfway point. So I know that is the midpoint of this line. What am I actually being asked to do? I'm asked to find an equation for M. Okay, so let's think what we need to do. We already know the equation of this whole line here. We know that that is y equals minus a half x plus 6, and I'm being asked to find this line here. Now, it looks like a perpendicular line. How can I prove that it's perpendicular? Well, this is a right angle. I mean, this is a rectangle, so therefore its angle is going to be a right angle. So I know that line M and line L are perpendicular. And what do you know about perpendicular gradients? hopefully you know that the gradients of perpendicular lines multiply to make -1. Okay, so either you know that, or you know that they are the negative reciprocal of each other. And all that means, let's say you had a gradient of 3, the negative reciprocal would be -1/3, because if you did 3 over 1 times by -1 over 3, 3 times -1 is -3 over 3, which would simplify to -1. Okay, so the negative reciprocal, whatever you have, if it's a whole number, you turn it into a fraction, flip it, and then whack a negative sign in it. If it's already a negative, then it's just going to be the positive version of that reciprocal. So I know that the gradient of line L is -1/2. So what is the negative reciprocal of -1/2? So I know that it's going to be positive. And what do? I just flip this fraction around. So it'd be +2 over 1, which would simplify in layman's terms to just 2. So I know that the gradient, where can I write this? I'll just write it here because we don't need this anymore. The gradient of line M, which I'm trying to find, is 2. How do you write an equation of any line? You write it as y equals mx plus c, where m represents the gradient of the line and c represents the y-intercept. So what could I write? Well, I can fill in the gradient, which is 2. So the first part would be y equals 2x plus c. Now what I need to do is find out what the y-intercept is, which is where the line crosses the y-axis. So how can I do that? Well, let's have a look at the information I have. I know that, I shouldn't have deleted the other one. What did I say the equation of that line is? It was y equals -1/2x plus 6. So that's my line L. If I have the equation of a line and I have a coordinate, I can use that to work out another coordinate. So over here, you know that B crosses the x-axis. Therefore, the coordinate of B is going to be 0 something. Sorry, other way around. It crosses the x-axis, therefore y is 0. So I could work out the x coordinate. How can I do that? By substituting 0 into this equation. So I'd say that 0 equals -1/2x plus 6. Therefore, if I took x onto the other side, half x equals 6, and it's a positive half because I've added a half x to both sides in order to cancel it out. So I know that half x equals 6, or I could write that as x over 2 equals 6. So times both sides by 2, and you know that x equals 12. So the coordinate of B is 12, 0. I then also know that I can work out this coordinate over here, because that is where the line crosses the y-axis. So that means that x is going to be 0, and I can find out the y coordinate. Once again, I substitute into the equation of the line. So I know that y is going to equal -1/2 times by 0 plus 6. Anything times 0 is 0, so therefore y must equal 6. So the coordinate of E is 0, 6. So I now have 2 coordinates that I can work with. And ideally, I need to find out what the coordinate of A is, because sadly, my line M doesn't go through anything else. I could have also figured out what the coordinate of D is, but that's a different way, so let's just stick with what we've done so far. So I now know that the distance from here to there, the y distance is 6 and the x distance is 12, because this coordinate here is 12 and this coordinate here is 6. I also know that this is the midpoint, therefore exactly the same distance is going to take place over here. So the y coordinates are going to go up by 6 and the x coordinates are going to go left by 12. So therefore, this coordinate here must be -12 and this coordinate here must be positive 12. So now I know that the coordinate of A is minus 12, 12, and that is a coordinate on the line of y equals 2x plus c. So I figured out what this coordinate is because my line goes through it, and if my line goes through it, I can use the x and the y value and substitute it into my equation to figure out what c is. So I know that when x is negative 12, y is 12. So let's just substitute that in. 12 would equal minus 24 plus c. So if you add 24 to both sides, you find out that c must be 36. So if c is 36, my final equation is going to be y equals 2x plus 36. So let's just write it here as well. It's a little bit of a long-winded one, but you just want to think about what you can play with. We could have also worked out the coordinate of D here, but let's not worry about it. We did it this way. Could have been a quicker way. I don't know. Whatever way you do is absolutely fine. Okay, so here we've got quite a tricky question that is going to involve us knowing our exact trigonometric values. So what I'm going to start with is just show you how to figure those out. There are loads of ways that you can remember it. You can just memorize the table, you can use the hand trick, but I'm going to show you how to use it, how to work it out using logic and triangles. So first of all, what I want to do, I'll write out the table here. You need to know how to figure out the values of, and when you're thinking of drawing out this table, just think to yourself, SOHCAHTOA. Okay, so what order is that said in? First I say sine, then I say cos, and then I've got tan. Okay, you need to know the values of each of these for 0, 30, 45, 60, and 90 degrees. So obviously you can memorize them, but I'm going to show you how you can figure it out if you kind of melt down in the exam and you forget everything. So the first one, because it would be a lot to explain this in just one little video, is just memorize the first three. So 0, 1, 0 is what you want to aim for. And if you always think of yourself, it's going to be SOHCAHTOA, you know that it's going to be sine 0 is 0, cos 0 is 1, tan 0 is 0, because it's in that order. Then what we do for 30 degrees, 60 degrees, and 90 degrees is we think to ourselves, okay, what triangle do I know that is used everywhere that has angle of 60 degrees? And that's just going to be our nice, friendly, bog standard equilateral triangle. Okay, so you're dealing with an equilateral triangle, and just for simplicity's sake, you could use any numbers, any side values. They'd all simplify to the same thing. We're going to use 2 because we're eventually going to half it. So just an equilateral triangle is going to have angles of 60 degrees because 180 divided by 3 is 60. Now, with trigonometry, I want to be using a right angled triangle. So what I want to do is just split this triangle in half. So I'm then left with a right angled triangle. Okay, now if it's a right angled triangle, then I obviously am only going to have half of this 60, which is going to lead to a 30-degree angle. This is going to be a 90-degree angle, and this will be a 60-degree angle. The side here will remain as 2. This is going to be half of the original base, so that would be 1. And I can use Pythagoras to find out what the length of this side here would be. So with Pythagoras, I've been given the hypotenuse. So I'd say c squared take away b squared equals a squared. So the hypotenuse is 2. So I do 2 squared take away 1 squared. Must give me a squared. What's 2 squared? That's 4. 4 take 1 is a squared. So therefore, a squared must equal 3. So how can I find the value of a? I'm going to have to do the square root of 3. So that is how I get this triangle. Now you could just memorize this triangle if you wanted to, but this is how you get there. So using this special triangle, I am now going to try and figure out what all of my values are. So remember with SOHCAHTOA, we always use that. And first, I'm going to work out what sine 30 is. So to work out what sine 30 is, I'm going to have to do the opposite over the adjacent. And what's that going to be? Well, this is my given angle, 30. The opposite is over here, and the adjacent is over here. So sine 30 would have a value of 1 over root 3. So that's the value of sine 30, 1 over root 3. The value of sine, let's do cos actually, the value of cos 30. So cos 30, what would I do? Cos is adjacent over hypotenuse. So the adjacent is over here, so that would be root 3 over 2. Do the same for tan. What is tan? Tan 30 is going to be opposite over adjacent. So tan 30 is going to be 1 over root 3. Okay, so 1 over root 3 like this. Now I can do the same for 60 degrees. So I'm going to have to rejig my triangle slightly because the sides are always based on your given angle. So if this is the given angle, this is the adjacent, this is going to be opposite, and this will be hypotenuse. So let's do exactly the same for all of my values. So sine 60 is going to be opposite over hypotenuse, so root 3 over 2. So root 3 over 2. Cos 60 is going to be the adjacent, 1 over the hypotenuse, which is 2, so that would be a half. And then tan 60 is going to be opposite, root 3 over the adjacent, which is 1, so that would be root 3 over 1. So for 90 degrees, it's a little bit of a strange one because over here we've got our hypotenuse, but that's also going to be our opposite. So for sine 90, what do I have to do? I have to do opposite over hypotenuse. So in this case, that is going to be 2 over 2, which is 1. So for cos 90, I need to do the adjacent over the hypotenuse. I can't actually determine which one is the adjacent, so I'm just going to have to write 0, and it's going to be over 2 because the hypotenuse is 2. Now anything 0 divided by anything is 0, so this value over here will be 0. Next I've got tan, and what do I do for tan? I'm going to do the opposite over the adjacent, but I can't actually determine which one is opposite, which one, what the opposite or the adjacent is, so it would end up being 0 over 0. So I just say that this is undefined, so you wouldn't be asked for this one. Okay, now for the next part, we have 45 degrees. So we need to think, how could we create a triangle that has 45 degrees? Well, I could just start with a basic right angle triangle of 90 degrees and an angle of 45, and another angle would have to be 45. So that's how I could do this. Now I just use a unit triangle, so I'm just going to say that side is 1 and this side is 1. So therefore, using Pythagoras, a squared plus b squared equals c squared, I'd say 1 squared plus 1 squared equals c squared. 1 plus 1 is 2, so c squared is 2, so c is going to be the square root of 2. Okay, so for the first 3 kind of values, you can memorize the first triangle or remember how to do it. For the next value, for 45, you're going to have to use this one. So we do all of our things once again. So if I were to work out sine 45, I would have to do the opposite over the hypotenuse. So let's quickly label our triangle. Let's use this angle here. The opposite would be over here, the adjacent over here, and the hypotenuse over here. So sine 45 would be 1 over root 2. So that would be 1 over root 2. Then to do cos 45, I would do the adjacent over the hypotenuse, which is 1 over root 2. And then for the last bit, for tan 45, I would have to do the opposite over the adjacent. So that is going to be 1 over 1, which is 1. So that is how you do the first part. Well, this is just how, if you get stuck in the exam, you can figure out what your values are. You may have memorized the table. If that works for you, great. You don't have to do any of this, but this is just how to work it out if you get stuck in a panic. So now I come on to the main part of the question, which is deciphering what all of this means. Now the table of values shows some values of x and y that satisfy the equation y equals a times by cos x plus b. So let's just start with the first values. So when y is 3, x is 0. So that would end up being cos 0 plus b. Now, thanks to my handy table, I know that the value of cos 0, why did it undo it? The value of cos 0 is 1. So I'd say 3 equals a times by 1 plus b. So 3 is going to give me 1a plus b. So essentially, I know for the future that a plus b must equal 3. Hasn't helped me find a or b, but at least I've got something. I then can try another value. So let's just try an easy one. So here we've got 60 and 2. So when x is 60, y is 2. So 2 must equal a times by cos 60 plus b. What's the value of cos 60? Well, cos 60 is a half. So 2 equals a times by a half plus b. So 2 equals a over 2 plus b. So that hasn't really taken me any closer to what I want. But hey, what can we do? 2 equals a over 2 plus b. Let's try another one. So I obviously want to figure out what the value of a and b are. So when x is 90, y is 1. So let's substitute that in. 1 equals a times cos x, and that would be cos 90 plus b. So cos 90 is 0, so 1 would equal a times 0 plus b. So 1 is b. Okay, so I know now, thankfully, that the value of b is 1. If I know that, I can just rewrite this equation to say plus 1. So now all I need to do is find out what the value of a is. So let's try this one. So I know that when x is 120, or actually, you wouldn't know that value. So let's just try another one. Let's try 60 and 2 again. So when x is 60, y is 2. So 2 equals a times by cos 60 plus 1. So 2, or actually if I subtracted 1, then I know that 1 equals a times by cos 60. What's the value of cos 60? Well, if I look at my grid, I already know that that is a half. So I know that 1 equals a over 2. So to figure out what a is, I need to times that by 2, times both sides by 2. So a is 2. So I've now figured out what my a variable is, what my b variable is. So I have an equation that will allow me to figure out what anything is. So I'll just put 2 over there. So I need to find the value of y when x is 45. So y would be 2 times by cos 45 plus 1. What's the value of cos 45? It's 1 over root 2. So y equals 2 times by 1 over root 2 plus 1. That would become 2 over root 2 plus 1. And I don't think we're asked to simplify it, but because you have an irrational number on the denominator, you're probably going to want to simplify it. So let's just have a look at what would happen. I'm going to want to rationalise the third. So that would end up being 2 root 2 over 2, which would simplify. Why did it delete? So that would simplify. 2 divided by 2 is 1 to just root 2. So this simplifies to just root 2. So y equals root 2 plus 1, or y equals 1 plus root 2, whichever is fine. Okay, so in this question, I am asked to show that this nice little fractional third can be written in the form a plus b square root 2, where a and b are integers. Remember, integer just means a whole number. So what I want to do, whenever I see a third, generally, if it's got a third on the denominator, I'm going to want to rationalise it, which literally just means untherding the third, so that you're denominator is a whole number, is an integer. So I write out my surd, and the denominator isn't just one thing on the bottom, there's two terms. So what I want to do when I've got something like this is I want to do the reverse. So I want to use something called the conjugate. Now the reason I do this, if you just think to yourself, if I had x plus 2 and I multiplied it by its inverse, so x minus 2, what happens? That becomes x squared minus 2x plus 2x minus 4. And these middle two terms, because one is a negative and one is a positive, they're going to cancel out. So I'd just be left with x squared minus 4. And that's exactly what I'd want to do with my surd, because I'd be left with the positive root 2 take away, well, and the negative root 2, so they'd cancel out. So I'm going to multiply this whole surd by root 2 minus 1. So all you want to do, plus 1. All you want to do to get the conjugate is look at the sign in between the two terms and flip it. If it's a negative, it's going to be a positive. So now I'm left with 2 brackets as my numerator, 2 brackets as my denominator, and I just need to multiply them out. So what can I do? Well, if you're really confident with expanding brackets, then just do it the way that you know. If not, then using the grid method is just helpful because it ensures you don't miss out any terms. So I'm going to write 6 minus root 8 and root 2 plus 1. So I'm just putting first bracket up here and the second bracket along the side, and then I just multiply. So root 2 times by 6 is going to give me 6 root 2. Root 2 times by minus root 8 is going to give me minus root 16. When you're multiplying surds, you literally just multiply them and put them under one surd. 6 times 1 is 6, and 1 times minus root 8 is going to give me minus root 8. So I'm left with 6 root 2 minus root 16 plus 6 minus root 8. Now when you've got surds, you're always going to want to simplify them. So we're going to have a look at simplifying root 16 and root 8. And when you simplify surds, you're looking for the largest square number. So it might be helpful to just write the square numbers to remind you. So what's the largest square number? Well, 4. I know that 4 times 4 makes 16, so I could just turn that straight into 4, or if you're doing it in the surd form, what's root 4? That's 2. Root 4 is also 2, so that ends up being 4. So if you spotted that that was a square number already, then you just simplify it to minus 4. So I'd be left with 6 root 2 minus 4 plus 6, and then I want to simplify the next surd 2. So what's the largest square number that fits into 8? That's 4, so I can write root 8 as root 4 times by root 2. What's root 4? That's 2, so that's 2 root 2. So I'm left with minus 2 root 2. And now that I've simplified my surds, I'm going to be able to collect like terms. Now remember that surds can be treated like algebra. So if you had 6a minus 2a, that would become 4a. So similarly, 6 root 2 minus 2 root 2 is going to become 4 root 2. So that would be 4 root 2, and then minus 4 plus 6 is positive 2. So my numerator is going to simplify to 4 root 2 plus 2. And then, so I'm going to do exactly the same with my denominator. So I do the grid. I'm going to put root 2 minus 1 and root 2 plus 1. So root 2 times root 2, remember that any surd multiplied by itself, so let's just do an easy one. Square root of 16 is 4, and what's 4 times 4? It's 16. Okay, so any surd multiplied by itself is its unsurd itself. So root 2 times root 2 is just going to be 2. That's going to be minus root 2, positive root 2, and then minus 1. So if I just expand that, or if I write that out, that would be 2 minus root 2 plus root 2 take 1. And that's the whole reason I do the whole conjugate where I'm multiplying the inverse, because these two terms are going to cancel out. So I'd just be left with 2 minus 1, which is 1. So that is what my final surd would be. And now anything over 1 is just itself. So that would be 4 root 2 plus 2. They've told me that I want to write it in the form a plus b root 2. So I'll just switch these around. So that would be 2 plus 4 root 2. And they haven't asked you what the values of a and b are, but if they were, you'd say a is 2 and B is 4. Okay, so in this question, I'm told that the two triangles in the diagram are similar. Now, if I know that two shapes are similar, then what that means is that one is an enlargement of the other. And if that is the case, then that means that all corresponding sides and all corresponding angles, well, all the corresponding angles would be equal, but all the corresponding sides are going to be in proportion to one another. So they're all going to have been enlarged by a scale factor. Now, I'm told that I need to work out that there are two possible values of x and that I need to state any assumptions that I make in my working. So I know these triangles are similar, but I don't know which sides correspond to which. The most straightforward assumption that you would make is you'd say, oh, okay, so this triangle here, if I just enlarged it, makes this triangle here. So therefore, the bottom two sides, so AE, must correspond to AD. So the first assumption that I would make is that AE is related to AD. So they are corresponding sides. Now, if I make that assumption, because I haven't been given any information as to which are the corresponding sides, then I would be able to figure out what the scale factor of enlargement is. So let's just draw these triangles out. I've got A, B, E, and then A, C, D. And the lengths are 12 and 15, because 12 plus 3 gives me a total length of 15 for AD. So I want to think to myself, what have I multiplied 12 by to get to 15? Easiest way to do that is to do 15 divided by 12, because then I can figure out what I do to get from 15 to 12. 15 divided by 12, simplify it, divide each side by 3. That would give you 5/4. So I know that the scale factor of enlargement must be timesing by 1.25. Now, because this is a non-calculator, I can leave it as a fraction. And I've been given this side here. I know that this side is 8. And I want to work out this total length here, which would be AC. So I'm going to do 8 times by 5/4, which gives me 40/4, which is 10. So this whole side here is 10. And therefore, x must be 2, as 8 plus 2 makes 10. So one option is x equals 2 if AE and AD are corresponding sides. So hopefully most of you were able to spot that one. The next bit is a little bit tricky. Okay, so using the first assumption, where I assumed that AE and AD were the corresponding sides, I managed to work out that x could be 2, but that is an assumption. I have not been told which sides are corresponding to one another. So there is another possibility. If this triangle, I just flipped over, so these two sides, if I switched them over, just imagine flipping the triangle over like that, then I'd be left with AE as this side here and AB as this bottom side here. So AB would be 8 centimeters and AE would be 12 centimeters. And that would be corresponding to my larger triangle, which can stay the same, which is ACD. So that now means that this 8 centimeters, because I've just flipped them round, so this line here now belongs here and the other way round. So 8 centimeters must be corresponding to the 15 centimeters. And the assumption I'm now making is that AB is corresponding to AD. Okay, so I'm saying that these are the two sides that are related. So therefore, let's work out our scale factor. Well, how could I work out the scale factor? I'd have to do 15. The scale factor is 15/8. So to get from this shape to this shape, I would divide by 15/8 and do the reverse. To go from the smaller shape to the larger shape, I'd multiply it by 15/8. Okay, so my scale factor of enlargement is 15/8. So now I want to figure out, this side would be 8 plus x still. So 12 times by 15 over 8. 12 times 15, remember that this is a non-calculator paper, so 12 times 15 using a non-calculator method, you can do doubling and halving. So if I halve one and I double another part of the calculation, then that gives me exactly the same answer. And 6 times 3 is 18, so you add the 0. So I know that 12 times 15 would be 180. 1 times 8 is 8. So then, once again, non-calculator, so I just have to simplify this. So you can keep on simplifying or you can jump straight to the bus stop. That would be 90 over 4 because I'm dividing by 2. And then that would be 45 divided by 2, which is 22.5. So I'm assuming that this side here now must be 22.5 centimetres. Therefore, 8 plus x equals 22.5 centimetres. So 8 is going to be, if I subtract 8 from both sides, 14.5 centimetres. And that would be my second value of x. So AB is corresponding to AD, then x is 14.5. So the assumptions you write down, when you have similar shapes, normally you have to identify which sides are corresponding and then you know what to work the scale factor out from, but we weren't told this information, which is why we have to assume. So we first assume that it's these two sides, and then we're like, oh, actually, if I reverse the triangle, then actually this side might be corresponding to this side. And it is a slightly tricky question because it requires you to sort of think outside the box, but that's how we do it. Okay, so we've made it to the last question, and this looks lovely because we've just been given some shapes with algebraic expressions and we're going to have some fun. So here is a rectangle and a right angle triangle. All measurements are in centimetres, and I know that the area of the rectangle is greater than the area of the triangle. So I can't form an equation, I'm going to have to form an inequality. And the sign for greater than is this one. So greater than, less than, I'm sure you already know, but just a reminder. So I need to find the set of possible values of x. So I'm going to need to set up an expression for myself. How do I work out the area of any rectangle? Well, the area of any rectangle is just going to be base times by height, or length times by width, or any of those, one side multiplied by the other. So I'm going to have to do x minus 1 times by 3x minus 2. And I know that whatever that is going to be greater than the area of the triangle. How do you work out the area of a triangle? Well, it's a right angle triangle, so I know these are the two perpendicular lengths. So I just do base times height divided by 2. So I'd do 2x times by x divided by 2, which is 2x squared over 2. And 2 divided by 2 is just 1, so I know that leaves me with x squared. Then I can just expand my brackets. So 3x times x is 3x squared. X times minus 2 is minus 2x. 3x times minus 1 is minus 3x. And minus 1 times minus 2 is positive 2. And I know that must be greater than x squared. So let's clean that up. 3x squared minus 2 minus 3 is minus 5x, and plus 2 must be greater than x squared. What I can do next is bring it all together. So if I take x squared from both sides, I'd be left with 2x squared minus 5x plus 2 must be greater than 0. So now I've got a quadratic inequality. So now that I've got my quadratic inequality, I can move on to solving it. So what I would need to do is factorise. Whenever you've got a quadratic, in order to solve it, you want to factorise it. First, make sure it's equal to 0 and then factorise. So if this was equal to 0, I would factorise it. Now, this is a quadratic with a coefficient of x that is greater than 1. So there are a few ways that you can do it. One of the best ways is to just use the grid method. You know that every quadratic is in the form ax squared plus bx plus c, and the ax squared part would always fit in the top quadrant. Bx is where these two values would add together, and c would be in here. So let's apply that to our quadratic. So 2x squared must be in this box, 2 must be in this box, and these two values, whatever they sum to, must make minus 5x. Okay, so I know that because it's 2x squared, my only possible way of making 2x squared is by having 2x and x. Then I need to think, okay, I've got two numbers that need to multiply to make 2, but also sum to make -5. The only way to make a positive number from a negative number is by multiplying a negative by a negative. So I know that both my values are going to be negative. The only factors of 2 are 2 and 1. So you can do this in pencil and you can scribble it out, or the more you do these, the more you start to notice things. So I know I want to make -5. I know it's going to be a negative number. -2 times by 2 gives me -4x, and -1 times by x gives me -1x. Now, -1 times -2 gives me 2, and -4x minus x is -5x. So I know that that is right. So I would factorize it to make it 2x minus 1, x minus 2. And if it was a quadratic, it would be very simple. It would be equal to 0, and I'd say that x is 2 or x is a half. However, it's not equal to 0. It is greater than 0. So in cases like this, what I want to do is just draw a quick graph for myself to determine what's actually going on. So remember, when you have a quadratic, what that means is that you're going to have like something like this, okay? A quadratic graph. Now, what would the values for x be? Well, like I said, if I solved it, I know that the value for x would be 2 or x would be a half. So I know that at 0.5 and 2, that is where my graph is going to cross the x-axis. So this is what my quadratic is going to look like. Now, what do I want from this quadratic? Well, I want to find the areas where 2x squared, which is this line here, this line represents 2x squared minus 5x plus 2. So I want all of the values where the graph, so where the pink line, is greater than 0. And if this represents 0, then all of these potential values are what I'm interested in. Okay, so nothing in between here, because that is below 0. So therefore, my possible values of x would be going this side, so when x is greater than 2, or going this side, where x is going to have to be less than a half. But this is a context question. So I need to think about what makes sense in the context of my question, which is working out area. If x was a half, would that make sense? So what would I get if I did a half minus 1? I would get minus a half. Does that work in the context of area? Can you have a negative length? No, you can't. So therefore, this value doesn't work. So the possible set of values for x would be anything that is larger than 2. That's my only possibility. So as always, thank you very much for watching. If you enjoyed this video, then make sure to like and subscribe, or maybe leave a comment. And if you have any further questions or want anything explaining in more detail, let me know and I can make a further follow-up video.